Hello everyone, welcome to the Bharat Academy. I am Manoj Thapliyal and today's topic is function. What is function? Roughly speaking, the term function is used to define the dependency of one physical quantity on the another physical quantity. For example, the volume of a sphere of radius r is given by v equal to 4 by 3 pi r cube. It means the volume of the sphere depends on its radius and the dependency of the volume v on radius r is denoted by v is equal to fr. Means v is the function of r. It means v is the function of r. Generally we can take it like this. Suppose x and y are two variables, and if the value of y depends on another variable x, then y is called the function of x and it is denoted by y is equal to fx. Generally in mathematics you take functions as x raised to the power n, sin x, log x, ex, and etc. It means the value of y depends on each value of x. In these cases, these are the functions. Now students, the function can easily be defined with the help of mapping. Now the function, what is the function? Let a and b are any two non-empty set, and the function f from the set a to set b is a rule or a method or a correspondence which associates elements of set a to elements of set b such that there should be two conditions. All elements of set A are associated to elements in set B. That is, second one is each element in set A is associated to unique element in set B. This is the first definition of the function based on mapping. And there is another way to define the function. A function f from the set A to set B is a specific type of relation for which every element x of set A has one and only one image y in set B, and we write it like this: f is a function from A to B, then y is f image of x, means the value of the function f at x. So this is written as y is equal to fx. It means we can define the function on the basis of relation, and it's quite obvious that function f is this subset of A cross B. We can also call it function f is also a subset of A cross B. Let A be the set of these elements 1, 2, 3, 4, and another set B is having these elements A, B, C, D, E. B, there are two sets A and B. Suppose this is set A and this set B. F1, the function is defined like this: set A contains 1, 2, 3, 4. Set B contains A, B, C, D. 1 is associated to D, 2 is associated to B, and 4 is associated to E. What does it mean? There exists an element 3 in the set A which is not associated to any element in set B. That it means f1 is not going to be a function from the set A to set B. Similarly, another example, suppose this is f2. From A to B is defined like this: if 1 is associated to A, 2 is associated to B, 3 is associated to C, 4 is associated to C again, and 4 is associated to E. Again in this case, 1 is associated to A, it's okay. 2 is associated to B, this is okay. 3 is associated to C, it's again okay. But 4 is associated to C and 4 is associated to E. What does it mean? One single element in A has two F images, which cannot be the case of the function. What is the definition of function? Each element of set A is associated to a unique element in set B, but in this case this 4 is associated to two elements C and E in B. Again, this f2 is not a function from A to B. Okay, now I take the third example. If set A, this is set A, this is set B, and the function is f3 from A to B. 1 is associated to A, 2 is associated to B, 3 is associated to B, and 4 is associated to D. So it's quite clear that all the elements in A are associated to elements of set B. It means f3 is a function from A to B. Again, f4 I have defined a function from A to B. 1 is associated to B, 2 is associated to C, 3 is associated to D, and 4 is associated to E. So what does it mean? Each element in set A is associated to a unique element in set B. In this case, f4 is again a function from A to B. समझ में आया? तो इसका मतलब ये हो गया कि फंक्शन में ए के सारे एलिमेंट किसी न किसी एलिमेंट से बी के एसोसिएटेड होने चाहिए. Here students, we shall define what is domain, what is codomain, what is range of a function. Let f is a function from set A to another set B. F is a mapping from A to B. Then the set A is called domain of the function f. Set B is called codomain of the set f. And what about the range? The set of f images of the element of set A is called range of f, and it is denoted by fa. Fa is defined as the set such that fx such that x belongs to A. It is called range of f. Means set of all f images of the element of A will be called your range. And range of f is always subset of codomain of f. Codomain of f. Codomain of f means set B. Fa is always subset of B. We can discuss it by this example. What is domain, what is codomain, what is range? Suppose we are given two sets. Set A contains these elements -2, -1, 0, 1, 2, and set B contains these elements 0, 1, 2, 3, 4, 5, 6, and a function f from A to B is defined like this. Fx is going to be x square. So on the basis of this definition, fx equal to x square, here each element of A, f A -2, f -2 its whole square is 4, f -1 its whole square is 1, f0 its square is 0, f1 is square is 1, f2 its whole square is 4. It means all the f images of all the elements of A 4, 1, 0, 1, 4 are also the element of set B. It means these elements f images 0, 1, 4 will be your range of the function in this case. Here, since f is a mapping from A to B, defined like this, fx equal to x square, on this basis the domain of this function will be set A. Set A means which contains -2, -1, 0, 1, 2, these elements. This is your domain. Set B, what is the codomain of f function? Set B. Set B is given this 0, 1, 2, 3, 4, 5, 6. Set B is the set containing these elements 0, 1, 2, 3, 4, 5, 6. This is your codomain. But range of the function is the set of all the elements of f images of all elements of set A. These are 0, 1, 4. The range of f will be the set containing 0, 1, 4. It's quite obvious that range of f 0, 1, 4 are also the elements of codomain of f, means set B 0, 1, 2, 3, 4, 5, 6. It's quite obvious that range of any function is always subset of codomain of that function. Now student, we come to the classifications of functions. There are certain classification of functions. First one is 1-1 function, and this is also called injective mapping. What is 1-1 function? A function f from the set A to set B is said to be 1-1 or injective function if different elements of A have different f images in set B. For example, if x1 and x2 belongs to A, then fx1 and fx2 will also belong to B. If we take fx1 equal to fx2 and if we prove that x1 equal to x2, so it means function will be 1 functions. If the functions are equal, the value of the variables should be equal. If x1 equal to x2, if we implies and implied by, if implies and implied by fx1 is not equal to fx2, so then again it means f is a 1 function. Let me explain it by this example. If f is a function from real number to real number, R means set of real number, and the function is defined like this: fx equal to x cube plus 2 for all x belonging to R. X are the element of real number. I have taken two real numbers x1 and x2 belonging to R. If the functional value at these two numbers are taken equal, fx1 equal to fx2, so on the basis of this definition, fx equal to x cube plus 2, it will become fx1 equal to x1 cube plus 2 and fx2 equal to fx2 plus 2. It means x1 cube plus 2 equal to x2 cube plus 2. 2 cancelled. This will be x1 cube minus x2 cube. It's equal to 0. If I factorize it, the x1 minus x2 bracket start x1 square plus x2 square plus x1 x2 equal to 0. Since x1 x2 are two real numbers, then their squares will never be equal to 0. In that case, if this is not equal to 0, then this is equal to 0. x1 minus x2 equal to 0, so x1 equal to x2. I have taken functional values are same, so then the value of those elements are also equal to same. It means fx1 equal to fx2 implies that x1 equal to x2. It means f is a 1 function or injective function. Now students, second type of mapping is many one function. A function f from the set A to B is said to be many one function if two or more elements of set A have the same f image in B. Then it is called many one functions. If there exist two elements x1 x2 belonging to A, and if their functional values are same, fx1 equal to fx2, but the element have no same value, fx1 equal to fx2, but x1 is not equal to x2, so in that case that is going to be many one function. Let me explain it by this example. Let f is a function from z to z. Z is a set of integers defined by this function fx equal to x square plus x, where all x are integers. Z is a set of integers. I have taken two elements x1 x2 belonging to the set of integer z. If I have taken fx1 equal to fx2, so from this definition it will become x1 square plus x1 equal to x2 square plus x2. Put all these values on left hand side, it will become x1 square minus x2 plus x1 minus x2. Then it will be factorized into factors x1 minus x2, x1 plus x2 plus 1 equal to 0. In first case, if first factor x1 x2 equal to 0, so x1 is equal to x2, it's okay. But in second case, if x1 plus x2 equal to 1, the x2 equal to minus x1 minus 1. So if x1 equal to 1, the x2 will be what? From this minus 1, this is minus 2. If you take two integers 1 and minus 2, if you take 1, so its functional value f1 will be 1 square plus 1, means 1 plus 1, this is 2. If you take another integer minus 2, f minus 2 will be minus 2 its whole square minus 2. So 4 minus 2, it will be what? 2. Or in that case, in case of 1, f1 was again 2. It means 1 and minus 2 are two integers which have the same f image in set B. It means f is many one mapping. Now the student, third type of function is onto function, which is also called surjection. A function f from A to B is said to be onto or surjection function if every element in set B is the f image of some element of set A. That is, fa should be B. Range it's quite obvious range of f should be codomain of f in this case. means for every y belonging to b, there exists some x belonging to a such that fx should be y. This is the condition for onto function. There are certain procedures to prove any function as onto function. Let f is a function from a to b. First of all, we choose any arbitrary element y belonging to b and then put this equation in the form of fx equal to y. Then we solve this equation for x in terms of y. If x in terms of y becomes x equal to gy, if for every y belonging to b, the value of x which is in terms of y also belongs to a, then f is an onto function. I will explain it by this example. Suppose f is a mapping from R to R. R means set of real number to set of real number, which is defined as fx equal to x cube plus 2, where all x are real numbers. Suppose y is any arbitrary element in R. R means domain. So we put fx equal to y. This becomes x cube plus 2 equal to y. X cube equal to y minus 2. X equal to y minus 2 is power 1 upon 3. As you know, y is taken a real number. Here y is in any arbitrary number which is a real number, and y minus 2 its power 1 upon 3 is again a real number. Okay, so here if y is a real number, then x is also a real number. I have proved this. And to show it onto, fx is defined x cube plus 2, but here fx, x is y minus 2 1 upon 3. So it will become f y minus 2 its power 1 upon 3. I will apply this definition here. It will becomes, in place of x here, y minus 2 power 1 upon 3. It will become y minus 2 1 upon 3 its whole power 3 plus 2. The 3 cancel, it will become y minus 2 plus 2. 2 cancel, it becomes y. The fx equal to y, that means f is a onto function. Now student, the fourth type of function is into function. A function f from a to b is said to be into function if there exists an element in b which has no pre-image in a, then the function is called into function. Suppose here is a function f from a to b. A contains a1, a2, a3, a4, b1, and the set b contains b1, b2, b3 and b4. It's quite obvious that the element b2 and b5 in the set capital B have no pre-image in A. So this is the case of into function. Now student, the fifth type of function is 1 1 onto. इसको bijection function भी बोलते हैं. A function from the set A to B is said to be 1 1 onto. Clear है definition से ही कि f should be 1 1, means fx1 equal to fx2. It implies that x1 equal to x2. Or second, it should be onto for all. If y belonging to b, there exists x belonging to a such that if fx equal to y, it becomes onto. So I will explain it by this example. F is a mapping from q to q. Q is the set of rational number. Given by this definition, it is defined like this: fx equal to 2x minus 3 for all x belonging to the set of rational number. For 1 1, I have taken two elements, q1, x1 and x2 of the rational number q. Again, if fx1 equal to fx2, so by this definition, this is 2x1 minus 3 equal to 2x2 minus 3. The 2x1 equal to 2x2, the x1 equal to x2. It has become it means f is 1 1. And for onto, if y is taken any element of the rational number codomain, the y equal to fx is 2x minus 3. So from this, x is y plus 3 by 2. If y is a rational number, so y plus 3 by 2 is again a rational number. Okay, then such that fx equal to x is y plus 3 by 2, y plus 3 by 2. From this definition, 2x minus 3, it becomes 2, y plus 3 by 2 minus 3, 2 cancel. This is y, the fx equal to y. So f is proved as onto function. It means f is a mapping from a to b, or f is a function from a to b is 1 1 onto, which is also called bijection function. इसको bijection function भी बोलते हैं. Now student, there is composition of function. What is composition of function? Let f is a function from a to b and g is a function from b to c. Then the composition of FOG is denoted by GOF, is defined as GOF of X is equal to GFX for X is the element of first set A. If X belongs to A and F is a mapping from A to B, F is a mapping from A to B, so then B will contain Fx, and if G is a mapping from B to C, so then this G mapping from B to C will be GFX in C. So now from direct from A to C it will become GOF, composite of mapping from A to C. So now I will explain it by this example. If F is a mapping from R to R, R is a set of real number, B a signum function like this, F mod X upon X. Everybody knows mod X equal to plus X if X is greater than 0, and this is minus X if X is less than 0. If this function, signum function is like this, mod X upon X, so this will be X upon X is equal to 1 if X is greater than 0, and if this is 0, if X is equal to 0, in X is less than 0, the mod X will become minus X upon X. This is minus 1, X is less than 0. This function fx is defined 1 if X is greater than 0, 0 if X equal to 0, fx is minus 1 if X is less than 0. This is the function f. And another function g from R to R is the set of real number, is the greatest integer function. Gx is equal to greatest integer function x. We have to prove that FOG and GOF coincides in this interval, closed left hand closed interval minus 1 to 0. Greatest integer means what? If this is denoted by like this, greatest integer x, it means if x lying between minus 1 to 0, minus 1 is less than equal to x less than 0, means greatest value of the greatest integer x will be minus 1 if x is less than 0. If 0 is less than equal to x less than 1, the greatest value of the greatest integer will be 0 if x is less than 1. So I will apply that definition over here. If x belongs to this interval minus 1 to 0, it means minus 1 is less than equal to x less than 0. The FOG of x from the composite definition of composite function, FOG of x means FGX. What is the value of GX? GX is greatest integer mod x. The greatest integer mod x will be minus 1 when x is lying in this interval between minus 1 to 0. The greatest value of the greatest integer will be minus 1 when x is less than 0. The f minus 1, if x is minus 1, the f minus 1 will be minus 1 means x less than 0. Its value will be minus 1. Okay, now again GOF of x, GFX. The G of fx is in this interval, x is lying between minus 1 to 0, to fx is minus 1. The g minus 1, minus 1 is less than 0. The minus 1 is less than 0. So this is the greatest integer, value of the greatest integer minus 1 will be minus 1 when x is lying in this interval. So in this case FOG of x is minus 1, GOF of x is minus 1. Both are same. It means both coincides in this interval minus 1 to 0. Now student, there is another type of function, that is inverse of function. What is inverse of function? If a function f is from a to b, is 1 1 and onto function, means bijection function, then we can define a new function from b to a which associates each element y belonging to b to its pre-image f inverse y belonging to a. Such function is known as inverse of f, and it is denoted by f inverse. That is, if f is a function from a to b, is 1 1 and onto function, then f inverse will be the function from b to a, such that fx equal to y. So what does it mean? Ki f inverse y should be equal to x. So if f is 1 1 onto, it means the function f must be invertible. For any function f to be an invertible function, we have to prove that that function is 1 1 onto. If function f from a to b is defined to be invertible, if there exists a function g from b to a such that guf of ia identity function on x, or fog is equal to ib identity function on y, or you can say in another way, the function g is called inverse of f, that is f inverse, or fof inverse of x should be x, since this is an identity function. Now student, the question based on the inverse of the function is, let a function f from positive real number to this interval, closed interval I must say, minus 5 to infinity, given by fx equal to 9x square plus 6x minus 5. The function is defined like this. Show that f is invertible. You have to prove that this function is invertible and also find its inverse, f inverse. Just I have taken two positive real number, x1 x2 are belongs to R positive, means positive real numbers. Positive real numbers means x1 x2 both will be greater than 0. The fx is defined and 9x square plus 6x minus 5. x1 x2 I have taken two positive real numbers. The fx1 will be 9x1 square plus 6x1 minus 5, and fx2 will be 9x2 square plus 6x2 minus 5. For 1 1, if fx1 is equal to fx2, so fx1 means 9x1 square plus 6x1 minus 5 is equal to fx2 means 9x2 square plus 6x2 minus 5. Minus 5 cancel, put all these values here. So this will be 9x1 square minus x2 square plus 6 bracket start x1 minus x2 equal to 0. I have factorized these values. It becomes ultimately x1 minus x2 into bracket start 9x1 plus 9x2 plus 6 equal to 0. I have already taken ki x1 x2 both are positive real numbers, means greater than 0. So in that case, this expression 9x1 plus 9x2 plus 6 is never going to be 0. If it is not 0, then x1 minus x2 equal to 0, so x1 equal to x2. I have taken fx1 equal to fx2. Now we have proved that x1 equal to x2. That means f is 1 1 function. For onto function, I have taken y, any element of the codomain. Y belongs to minus 5 to infinity. This is closed interval. Let fx equal to y. Fx means 9x square plus 6x minus 5 equal to 0. I have taken y there. This becomes quadratic equation in terms of x. 9x square plus 6x minus bracket start 5 plus y equal to 0. This has been taken as a constant. So by Sridharacharya formula, x becomes minus 6 plus minus under root b square 6 square 36 minus 4ac 36 plus 36 into bracket start 5 plus y upon 18 minus 6 plus minus 6 under root y plus 6 upon 18. 6 is taken common, that this becomes minus 1 plus minus under root y plus 6 upon 3. That there are two quantities. If I take negative, if x is taken negative, x equal to minus 1 minus y plus 6 upon 3, that this whole number is a negative real number, but you have to take positive real number, which is not a positive real number. So then I take the positive sign. So this x will be minus 1 plus under root y plus 6 upon 3, which is a positive real number. The fx, I have taken f under root y plus 6 minus 1 upon 3. Fx is 9x square. Fx is 9x square plus 6x minus 5. So this is your x. So you have applied that formula 9 its square plus 6 into this minus 5. So ultimately, after solving, fx equal to y. If fx equal to y means what? F is a onto function. I have already proved that f is 1 1 function and f is onto function. So we know if f is a 1 1 and onto function or bijection function, that function is always invertible. Any 1 1 onto function is invertible function. So this means f is invertible. Now I will try to find the inverse of f in this case. As you know, if f inverse is the inverse of f, so by definition of composition function, f inverse of x will be identity x. The f inverse means GOF of x, it becomes GFX. It will become f of f inverse x is equal to x. So you know f of x is f function, fx means 9x square plus 6x minus 5. So here f of f inverse x will become 9f inverse x whole square plus 6f inverse x minus 5 equal to x. So I have made it perfect square. So this becomes 3 f inverse x plus 1 its whole square equal to 6 plus x. So now again if I take under root, so 3 f inverse x plus 1 becomes under root of 6 plus x. The 3 f inverse x will be under root 6 plus x. This one will go there, this is negative. The 3 f inverse x equal to under root 6 plus x minus 1. The f inverse x is equal to under root 6 plus x minus 1 upon 3. This is your inverse function. Now student, if you have found this video interesting and helpful, like my video and subscribe my channel. Keep watching my channel. I will be back very soon.